In today's tutorial, we're going to look at percent composition, so have your calculator handy for these calculations. Now, percent composition is all about the part over whole times 100 to get that percentage. Now, part means whatever one you're looking at. Sometimes it will ask you for a particular element or compound in what you need to look at, and the whole is adding up everything you have. So I'm going to show you two different problems you might see with percent composition. So our first one says an 8.20 grams of magnesium combines with 5.0 grams of oxygen. What is the percent comp of both? So we're going to do both of our parts divided by our whole times 100. So I'm just going to do my two little setups right here, and then I'll be able to do one for each. Now I'm going to have Mg here, O2 here. Now notice that it's just O2 and not just O, because O2 is a diatomic in our Brinkelhoff series, so it's never going to be by itself. So we're still going to represent it as O2 because we know better than that. Now, it won't affect our number because we're doing part by whole. So Mg's part is 8.20 and oxygen's part is 5.40. Now, how do we get the whole? To get the whole, we're going to add up both our parts. So 8.20 plus 5.40, and we're going to have 13.6. So we put 13.6. 13.6. Now looking at it, we'll see that magnesium is going to have the higher percentage because it's a higher part. So in our calculator, we're going to do 8.20 divided by 13.6 times 100. Now we have 3 sig figs and 4 sig figs, so I'm going to take it to 3. So I'm going to have 60.3%. So we can already kind of guess what our percentage of the next one's going to be. It's going to be roughly, it has to add up to 100, about 40%. So let's prove it. We're going to have 5.4 divided by 13.6 times 100, and we're going to have 39.7%. Now the easiest way to check yourself, so the check is that you take both of them and they add up to 100. So 60.3, 39.7 equals, so 60.3 plus 39.7 is 100%, and we got it right. So that's the first type of problem you may see. They'll give you a mass and then you calculate the percent comp from that. Now the next one is looking at the percent comp of just a given compound. You're not given initials. Now once the comp of our carbon and our hydrogen within this propane formula. So we're going to have our carbon here, our hydrogen here, and we're going to have our parts over whole times 100. So we're going to have to calculate the molar mass. Now we're going to have 3 C's, each at 12.01. Now I got 12.01 from the periodic table. When we look at our H's, we're going to have 8 times 1.01. So when we do the math, we're going to have 36.03, and we're going to have 8.08. Now each of these are parts by themselves. So we're going to have 36.03 here and 8.08 here. When we add them up, this one's going to represent our whole. So let's do 36.03 plus 8.08. We get 44.111, and that's going to go on the bottom of both of these. Now to complete our percent composition, we're going to do 36.03 divided by 44.11 times 100, and we're going to actually have it to 4 sig figs, so we're going to do 81.68%. Now does this answer make sense to us? Well, 36 out of the 44 is made up of carbon, so yes, it does make sense. Now, thinking that this is approximately 82, so it has to be about 18%. So let's double check. 8.08 divided by 44.11 times 100, and we're going to get 18.32%. Now don't forget to do your check. So we're going to do 81.68 plus 18.32, and does it equal 100? So 18.32 plus 81.68 equals 100%, and we've got it. Thanks for watching on percent composition, and I look forward to seeing you guys watch empirical and molecular formula next.